Okay guys, Miss O'Connell here. So today we're going to be talking about conservation of energy, okay, which we know is also sometimes called the first law of thermodynamics. And what this states is that all energy in a closed system is conserved. Okay, energy can never be created or destroyed. It can only be transferred. Okay, so this should sound familiar to you. You've talked about this once before in class. So in terms of equations, what this means is that the sum of the initial energy in the system must be equal to the sum of the final energy in the system. Okay, so that states that energy must be conserved. The types of energy that we have talked about so far are gravitational potential energy and kinetic energy. So I'm just going to add that to our equation here. So we have potential energy before plus kinetic energy before equals potential energy after plus kinetic energy after plus any energy that is lost as heat due to friction during an interaction. And we're going to represent thermal energy using the capital letter H. Okay, and again, that H stands for heat. Okay, or thermal energy. So this equation here we call that the law of conservation of energy. We can use that formula to determine how energy is transferred within a system before or after a motion, before or after a collision. Okay, and all these energies are measured again in joules, which we use a capital J to represent. Okay. So let's take a look at an example. Okay, so in example 1, we have a 5 kilogram object launched upward with a velocity of 24 meters per second from a position of 18 meters above the ground. Determine the velocity of this body when it hits the ground. Okay, so the word ground is cut off there, but we want to figure out the velocity of this object when it finally reaches the ground. Okay, so the first thing I'm going to do here is draw a diagram. Okay, so I'm going to draw a diagram. So I have my ground position, y initial, is equal to 0 meters. Okay, 18 meters above the ground I'm going to change this to y initial because our object starts at 18 meters above the ground. It's going to end at a final y. A final y of 0. Sorry, it's a little messy. I'm trying to use my finger to draw these heights here. So I'm going to start at an initial height of 18 meters There's our ball. Okay, starts at an initial height of 18 meters. It will end at some time later on the ground at 0 meters. We know that its initial velocity is 24 meters per second. Okay, so we know that it's launched upwards. It's going to continue to move until it hits a maximum height, and then it's going to fall back down towards the ground. Okay, it's eventually going to land at a y position of 0. Okay, so from this interaction, we know that if an object is launched upward at a velocity, some height from the ground, this is type 3 freefall. Okay, so when it reaches its maximum height, its maximum position from the ground, it's going to have a y velocity of 0. Okay, for a brief instant before it changes direction and moves back down towards the ground, its velocity is going to be 0. So using that information, okay, the A is a negative 9.8 meters per second squared. V final at this position, max height, is going to be 0, and then our initial velocity is 24. We can determine the total height above the ground, delta y. Okay, once we determine that, we can then use conservation of energy to figure out its velocity when it hits the ground. So first we're going to look at it, the first part of our problem, type 3 freefall. Okay, we're going to use one of our big 4 equations. V squared equals V naught squared plus 2 times A times delta y. V at the max height is going to be 0. So I have 0 squared plus 24 squared plus 2 times negative 9.8 times delta y. Okay, so 24 squared, I'm going to get 576. I'll move that to the other side of the equal sign, so I'm going to have negative 576 is equal to negative 19.6 times delta y. Divide both sides by 19.6, and I get a delta y value of 30.3 meters. Okay, so 30.3 is the height from the initial position to the maximum height. Okay, so that's the delta y we just solved for. I want my total delta y, which will be delta y plus my initial y position. So I'm going to have 30.3 plus 18 meters I'm going to get that my total delta y is equal to 48.3 meters. Okay, so the object's total height above